Welcome to our webinar series called Expert Speak, hosted by DataMites. Our speaker for today's webinar is Mr. Nitin Kumar Sharma, and the topic is on reinforcement learning. Let me give you a brief about Nitin. He is a senior data science engineer with extensive experience in solving real-world problems while working on quality prediction, anomaly detection, and customer lifetime prediction in the supply chain, retail, healthcare, automobile, and the e-commerce domains. He has been helping businesses across different domains with visual analysis, descriptive analysis, different matrices and models to improve business strategies. Over to you, Nitin.
Thanks, Ram. Hello, everyone. As Ram already introduced me, my name is Nitin Kumar Sharma. I'm currently working as a senior software developer in machine learning in one of the US-based IT MNC. I'm total holding 8+ years of industrial experience, and I developed a lot of projects. So, as today's topic is reinforcement learning, and I believe every participant who has participated here has, the basic knowledge about the machine learning, what is machine learning, how many types of machine learning we have, and what are the differences in different types of machine learning. So let me walk you through the agenda that we are going to follow today. So in the beginning and in the last of this webinar, we will be having one poll just to have the understanding in the beginning whether we have the same background or not, we have a little understanding of the machine learning or not. At the last, we will be having one more poll just to check whether we have some improvement in our learning, or what exactly we get from this particular webinar. So the first poll will be the first part of this webinar. Secondly, we will understand what is reinforcement learning. And later on, we will be discussing about the applications of the reinforcement learning and what are industries who are working on the reinforcement learning. The concept we will understand of the self-driving car. We will only understand the concept how the self-driving cars are developed and how they are going to be developed. What are the technicalities that we are going to use in the self-driving car. We will do a small implementation of the self-driving car as well in this particular webinar. And finally, we will close up with a final poll. And at last, we will be considering the questions from different participants if they have any. So coming to the next slide. This is a very common question, which is the most widely used machine learning type. So everybody knows there are three types of machine learning: supervised machine learning, unsupervised machine learning, reinforcement learning. So I hope everyone has a clear understanding what are these three types of machine learning, but still I would like to give you a brief introduction about all these three. Supervised machine learning. The supervised machine learning is the simplest kind of machine learning we can say, in which we know the target variables, we know the input variables, only we need to apply different machine learning algorithm to achieve the maximum accuracy of the models that we are going to develop. So in supervised learning, we know the inputs, we know the outputs, and we have to apply some algorithms. That's it. In unsupervised learning, we know the input variables, but we are not clear with the output variables. So what we do, we just try to make the group of input data of same categories, like we make the clusters, and further we apply different kind of ML algorithms to achieve the maximum accuracy for the model that we are going to develop. So this is the main difference between the supervised and the unsupervised machine learning. Coming back to the reinforcement learning. In the reinforcement learning, neither we know the input variables nor we know the output variables, what we are going to achieve, but we know the final goal, what we are trying to predict. So as we don't know the input variables, so there is one agent which do some hit and try methods. So for every efforts that he's putting, he's making some positive or some negative efforts. So accordingly, they will get the reward or the penalty, and the model will learn from these actions. So here I would like to, ask one question to all of you, which is the most widely used machine learning type in industries? So for answering this question, what you need to do, I'm just pasting one link on the chat of this particular webinar. You can go and access this particular link. This link is valid for 20 seconds. So once you will open up this link, you can fill your name, and then after, if you it's total up to your choice, you can fill up the name, or you can directly go to the answer page and can provide your answer. So I'll wait for next 20 seconds, and then after we will move on to the next slide. So I'll wait till 6:20, then I'll move to the next slide. I hope everyone has given their responses. So %, people has said the supervised machine learning is the most widely used, ML type. The 15% has said unsupervised learning, and 8% has said the reinforcement learning. I'm not individually going to ask person how they have said the unsupervised learning is most widely used. Maybe they have worked on that particular field. So yeah, right now the supervised learning is the most widely used in the industries. That is correct. But in the future, definitely the reinforcement learning is going to play a big role in our daily life as well. Now, if I see that how many of people given the answer. So here we see the names who has written their names. Coming to the reinforcement learning, the topic of the today. What is reinforcement learning? As sometimes our task has not been done, then we get scolded by our teachers, by our parents that no, you have to do this task. They usually reinforce us to do something, right? Similarly, the reinforcement learning is the training of machine learning models to make an optimal decision using experiences. So here in this slide, I would like to explain two things. There are 5 main, these fundamentals value you have to understand, that what is environment, what is the state, what is reward, what is policy, what is value. Until we will not be clear with these 5 concepts, we will not be able to understand what exactly the reinforcement learning and how it works. So suppose this is one agent, and it is taking some action. It has to reach here. This is the goal of the agent. The agent know the goal, and agent start following some path. Suppose initially it is following this path, and this is the wrong path or the long path. So it first goes right, got the penalty, came back to the same place, and again goes here. And this was the the right path and the shortest path to reach the goal. From here, it cannot pass because there's a fire. So what reinforcement learning does, there's one agent which performs some actions in the environment. On basis of those actions, it gets some rewards or the penalty. So it depends on the actions that they are performing. State defines the current state. Suppose the agent current state is this, he got the penalty, and this is the next state that he received, right? So I hope we are a little bit clear with these things. Now one by one, what is environment? Environment is anything physical world in which the agent operates. Just like we can take the example of a dog. A dog is roaming around in an open area, and the man is also moving there. And man, we can expect it as a agent. Man is the agent. If a agent will take any of the action, suppose agent will start throwing the stones on the dog, then what will happen? The dog will give some responses. The dog may bark the human being, the person. So every time agent do some actions in the environment, and uh, the agent received some reward or the penalty. Even if I'm naming it as penalty, but it is also it will be counted as reward. The reward may be the positive reward or the negative reward, but it will be counted as a reward. So I hope the concept of the reinforcement learning is clear. We have an environment. In the environment, we place one agent. Agent performs some actions, and those actions define whether the agent will receive the reward or the penalty. If the agent is receiving the penalty, it will not repeat the same task, and it will again perform the different action, right? So this is what the basic concept of the reinforcement learning here. After understanding the basic concepts of the reinforcement learning, I would like to tell you that what are the different applications that we are currently using in our daily life or in the current scenario where the reinforcement learning is going to be used. Then after, we will be understanding that which companies are going to use them and for what purpose. Right. So if we look into the applications, if I read one by one, I think it will take a lot of time. So I'm just considering few interesting one. Like the first one, applications in the self-driving car. So I think this is the most common and most interesting application. I think many of the people has read a lot of news about this particular application of the reinforcement learning. We will talk about this application in detail in the next slides. Coming to the next application, reinforcement learning in gaming. How it is, how in the gaming it is working. We will also see one demo of this reinforcement learning in gaming. Like probably, I believe in the childhood, most of you has played a lot of video games like Mario, or there are a lot of video games. Like so, on those video games, what happens? Sometimes we start playing, we got failed, then we got failed again, we got succeed with level 1, then we go to the level 2, and so on. So what happens? Now we will be having one. We are programming one machine or one algorithm we are programming that will cross the level 1, level 2, and every intelligent work that human is doing, right? So reinforcement learning in gaming is also in in progress, in development, and for many of the games, I think we have available agent who can play the games without any lose. The next one is the reinforcement learning in robotic manipulations, industry automation with reinforcement learning. Like to understand these two examples, we can understand if we know the manufacturing unit of a car. What happens? We have different components and we assemble all the components all together using the automation, right? For the automation, we generally use a PLC SCADA, but these days we use the robotics for the automation and the manipulation. So we have the different part of the cars, and just we we add up all the parts, we just assemble all the parts, and we make the car only. So what is the maximum time it takes to assemble a single car? Actually, it depends on different manufacturer to manufacturer, but it is very surprising that it takes around 1 minute or 50 seconds to assemble a single car. When you have all the parts available to assemble a car, it takes around 1 minute or less than that. So in that particular way, we have the automation process with us. But suppose anytime a new sensor is introduced, then we have to make some changes in our automation system. So there we are also trying to use the reinforcement learning. So if any small changes are happening, or if we would like to increase the accuracy in spite of having the 1 minute of time, if we would like to reduce it to some seconds, then definitely the reinforcement learning would be a big player. Coming to the next application, there are a lot of engineering applications that we have for the reinforcement learning, even in the NLP. NLP is the natural language processing. I think everyone is having a small idea what is NLP. Every time when we do the chatting with any of the agent, suppose for the online support in any of the website, maybe the Flipkart or something, we are just doing the live chatting with the agent. Sometimes it is the virtual agent. So that was done by the NLP, the natural language processing. Whatever the inputs we are providing, the code that we have written, and the model that we have created using the NLP, it gives us the responses. Now, once we have all the possible messages that we have feed in our model, we get the responses accordingly, right? So in the NLP, what the reinforcement learning is doing, because we don't know that what are the new messages can be expected by the user, because different users can send us a same message in a different way, like what is your name, or how I can introduce you. There are different way of asking the name of a person. So we have to feed these all different ways to the model. And in case we forget to feed one or two types of different way, then definitely the reinforcement learning model will be the main player in that way, that can understand the meaning of the sentence and can reply accordingly. We don't need to make everything in the model. The next is the real-time bidding reinforcement learning applications in the marketing and advertising. That is, quite clear. Even in the marketing, we don't know what are the new statistics are coming and on what basis we need to make the new sales graph, or whatever the different graphs we have to predict. So for every time we are getting the different data, and for the different data, we cannot make a system which can predict accordingly every time. So we need one agent, one system which can work as a human, which can predict every new statistics in a different way. Now coming on to the next thing, I'm just opening here the Google, and I'm just searching for the companies which are working on the reinforcement learning. So if I search on the Google, the list of the industries using the reinforcement learning, then if I'll go down, I'll find a few links. If I'm opening this link, I will be seeing there are many private companies which are founded in 2014, 15, 16, and most companies are from the USA or UK, Canada, Germany, right? So these are the different companies which are using the reinforcement learning. So we can, there are a lot of startups has been done when the machine learning was introduced in around 2014. So these are the different companies which are working on the reinforcement learning. Now the question is, there are three types of machine learning. What is the best which we should start focusing on our skills? I mean, which skills we should grab to make a place in the industry, right? So industry, we can fill the industry requirements, and we can help industries to develop some new projects, or we can help industries in some projects. So supervised learning, we should learn the unsupervised learning or the reinforcement learning. So for answering this question, I would say, like, every type of machine learning having its own limits, its own directions, and its own particular area in which we can develop different things. Like the current project in which I'm working is based on this supervised learning only. I'm working with one retail project, and in which what we do, we just place few products inside one particular fridge, and we are just monitoring each and every item in that particular fridge. So that we are just accomplishing by using the supervised learning only. So there are different learning. It depends on the industries in which you would like to go. So here I would like to, in this particular slide, I would like to give you an idea that what are different industries which can help you to work with. And suppose if I'll be taking the example of this InstaDeep, we can go to this particular company website and we can see what the project it is working on, what are different technologies it deals with, right? We can go to the products of this particular website. So these are different, products that was developed by this particular startup. Similarly, we can, these are two products, which are one is free, one is having some cost. So this is exactly, we can find out different industries which are working on the reinforcement learning. Now, till now, as we have discussed about what is the reinforcement learning, as we go to our agenda again, the first full was done. We got an understanding what is reinforcement learning, applications where we use the reinforcement learning, the industry is working on the reinforcement learning. Now we are going to move with the concept of self-driving car. So before explaining the concept of self-driving car, I would like all of you to look into one video, which I'll be explaining you when you will be seeing that particular video. Let me play with this started. This is a training phase. I'm just muting the sound of this. So what is happening? We have placed 3 cameras in the front of this particular car, right? This is the first camera, this is the second camera, this is the third camera. To the left side, right side, and in the front. Now what is happening? The epoch. What is epoch? Epoch is the number of times we are training our model. Suppose we have a set of 100 inputs, and we are training our model 10 times on every set of input, then there will be 10 epoch. And if we are making the batch of 10 inputs, so there will be 10 sets of 10 inputs. Then if we are running it for one epoch, so it will be run 10 times in a batch. So the batch size is the total number of inputs we are dividing in different groups or different batches is the batch size. The epoch is, in simple terms, the epoch is the number of times we are training our model on top of the input data set that we are having. So we will see that we are training this model how to turn right, how to turn left. So first it is getting some training. Multiple times it is making the mistake. As in the first slide, we have seen the agent was making the mistakes. And after making some mistakes, it got learned that if we are getting any wall, then we will be running in the front side. Now, if I talk about in the technical terms, what it is measuring, there are 3 sensors, which are the distance sensor, which tells us the distance between the particular sensor and the object. So if we will see here, suppose if I'm counting in terms of inches, suppose this is a 10-inch distance, 2-inch distance, 20-inch distance. So probably it will understand that this side is more open and we can move here. And then we can set in our program, like If the distance is less than 2 inches or it is of 2 inches, then the car will not move in that particular direction, right? So this is how we are training. First, we have trained this car to turn to the left side. Now we are training it to turn in the right side. So if we will see closely, it is measuring the distance from the sensor to the object that we are getting. After 150 epoch, the car learned to drive. I mean, it learned that if we are getting any obstacle to the left side, if we are getting any obstacle to the right side, it will not turn to that particular side and it will go to the straight. Even so, this is how the car is learning slowly. If we will count here, what is the essential thing that we require to train this particular model for the car? The sensor data, the distance between the obstacle and the sensor, the distances we need to have, and we just need to have the speed of the car, right? Track may be different. Even if we are making the self-driving car track basis, then we need the track as well. But here this is the general purpose self-driving car, so we just need the self driving car speed and the distance of these sensors from the obstacle. So this valid model can run safely on any other tag. The model can avoid obstacles as well. So if you will see if any obstacle will come in the path of this particular car, it will treat it as a same wall. All the obstacle, it will not turn here. Even a person is coming, then it will find its way to move on. So even it can run on the different tracks. So before moving ahead, let me write it down what we understood from that particular video. The first thing is we need the distance between sensor and obstacle, or we can say object. The second thing we require, the speed of the car. If we are having these two essential parts, we can start making our training. So what I did here is I just made a small code. I just got it from somewhere. So what we need to do here is we just need to assign the distances and the ball boundaries. These are the ball boundaries. If I have some particular track where I would like to run my car, then I will just provide the track dimensions here, X and Y positions. We will provide the track here, and after providing the track, so here, this is the track I would like to show you here. This is a particular track on which we are running our car. This is what the track we designed. And this is the car that we are going to run on our track. So this is we have the small pixels here. So this is the car that we are going to run on that particular track. So when I'll be running that, if you will see, it is the episode 10, the score is -1. Every time the score is -1, it is getting the penalty. So here you can see the speed and the points. we have received the 0 points. It means we have not achieved any positive actions through this particular model. We have to train at least, for 30 minutes to get some results. Here the speed is -4, which means, I think it's not updating. Let me rerun this. Right. If it is stuck in here, then we have our training is still going on. It will the maximum epoch it will complete. Yeah, in the training, what we can do is either we can assign the number of epoch we would like to train for, and it depends on total on your the data set that you are having, and the number of parameters that you would like to train. Like, for example, what is the best way if initially you don't know that how many epochs we should use? Is a question, then initially there's no straightforward answer that you should use 1, 2, or 2000 or some number. How many epoch you should use for the training? The right answer is, suppose initially you are getting, for example, you are getting 60% of accuracy, and later you start getting 65% of accuracy, and at some point of time you got 88% accuracy. Later you get 92% accuracy, and at some point of time you start getting 99.9% accuracy. That is fine. If you are getting 91.5% accuracy, the accuracy is going down. Then you get 87% accuracy. Then suppose here your epoch was 2000. Here your epoch was 1500. Epoch was suppose 1000. Here epoch was suppose 500. So what you will do, you will just stop your training at that particular epoch where the accuracy of your model start decreasing. There may be some other scenarios like after 87%, you get the accuracy of 93%, and then again 88%. So once you are getting this kind of scenario, you have to wait until your model is not achieving the great accuracy. Keep waiting for at least 5 to 10 more minutes, or at least for 100 more epochs. If you are getting that the accuracy is decreasing, then definitely you will select this particular number of epoch to train your model. Otherwise, what you will do, you will just continue your training for 100 more epochs. It totally depends on your data size. And once if you think that then after you're not in your accuracy is not increasing, then you will finally select this particular number of epoch, and you will start doing the training for that. Like if you will see here, it trained only for 25 episodes, and I think you might have seen a few variants here. The car was initially here in some epochs, then after. So until and unless the full training will be done of this particular track, then this car will run from here, will follow the full track, and will reach here. So what we are doing here in this, using the reinforcement learning, we are teaching this particular car or agent that how you should run on this particular track. So this is essentially the concept of the reinforcement learning that we need to understand. So let's have a look at what we have done till now. we have done with the concept of self-driving car using one video. In that, we will be having one car which contains 3 sensors, front, left, and right. And every time when it is moving in different direction, agent is doing some wrong or negative actions, we are getting the penalty. The car was, getting stuck somewhere. So every time we will be just reverting our action, and again we are doing some other actions. So this is how we will be training our agent. And after doing some training for different epochs, around 50 or 100, some number of epochs, then we find like the self-driving car is working, having the better performance than the initial epochs. Then we have seen the small implementation of the self-driving car. And this was just an implementation, not an industrial project. So now I think we are ready to move on the final poll. And then after, we will be considering the few Q&A questions and answers. We will be having that sessions. So the last poll here is, what could be the state vector for Atari Breakout game? There could be multiple options, correct? This is Atari breakdown games that probably everyone has played. So if we would like to make the reinforcement, we would like to utilize the reinforcement machine learning to train the agent to play this particular game, then what are the parameters that we need to have? The first one is the wall coordinate, where the wall currently is. Do we need to have the coordinate of this? Yes or no? Just think about it. Wall velocity. Do we need to know the wall velocity of this particular wall? How fast it is moving? The next one is pedal position. Do we need to know the position of this particular pedal to run this particular game? The last one is coordinate of remaining bricks. The coordinate of these bricks which are still remaining. What are the essential parameters that we need to have? To train our reinforcement agent. Then what are the essential parameters? Just answer this in your own. And here I'm going to show you the answer. The answer is, we need all the 4 parameters to train this particular agent for using the reinforcement learning. So I hope everyone got an idea about what is exactly the reinforcement learning, how we train different agent using the reinforcement learning, what are the essential parameters that are required. So here I'm wrapping up, and we can start our Q&A sessions if anyone has any questions. Over to you, Ram.
Hey, thanks, Nitin. I would request all the participants, if at all they have any questions, to either raise your hand up or to put it in the chat for us to put it to the speaker to answer.
Here I got one question. Can reinforcement learning be used in medicine to treat future diseases that may happen to the mutation over time? For this, let me again go to the applications. I think in the healthcare sector, I included that. So let me tell you, yes, definitely. You might have heard that the robotic surgery has been started, but they are not the big success as of now. So the reinforcement learning is going to be the very big player in the medicine side, in the surgery field. And about the medicine, I would say maybe 3 months back, I was talking to a company which was planning to install the vending machines, which can provide the medicines for the normal diseases. Like if you got the fever, you don't need to go to the doctor. You just go to a vending machine and you will check your temperature and explain your problems. And the vending machines will directly provide you the medicine. So yes, I would say the reinforcement learning is being used in the medicine field. So.
Yeah, I don't see any hands raised up. Uh, Nitin, generally, if you can actually come up with what are the kind of typical uh, questions which come up to you normally when you're, you try to, engage with people on this topic, right? Like you can come up with any kind of, typical questions from your side, which you generally get asked about.
Sure. Let me answer this question first. When we design RL, do we need to add other parameters in order to make accurate? When you are saying the other parameters, I'm not sure what you are exactly asking, but in short, I would like to answer this. As I have told you, in the supervised learning, we have the input and output. We just apply the ML algorithms to get the best model out of which can give us the best accuracy. Similarly, in the reinforcement learning, what we don't know the inputs. We have to make some actions. The agent will make some actions, and accordingly he will get the rewards. And so we don't need to add any other parameter. The agent will perform some actions, get some rewards, and the time when the model will get the better or the closer to the expected accuracy, we will stop doing the training of that particular agent, and we will expect the RL model was created. So there are different algorithms that we apply on top of this particular actions that agent is performing. What is the future of the reinforcement learning? As it is very clear, the machine learning, I mean the traditional machine learning, can solve many problems, but it cannot solve the real life problem which can be solved by the human being more accurately. So reinforcement learning can help us to solve those problems, those skilled problems, I would say, which only human can perform better these days. So using the reinforcement learning in future, even the machines can do the skilled job as the humans are doing right now. Out of various ways in reinforcement, positive, negative, punishment, and the extinction, what are the use case for each? Yeah. When you are saying the use case of each, there's no use case of each. These are some different terminology that we use in our reinforcement learning, type of machine learning. We use a different terminology, and these terminologies must be understood while we are training any of the model, right? So until and unless you don't know what is the positive and negatives, what is the punishment and what is extinction, then I think you won't be able to run that particular job. Like if you see in this particular example, it is getting -1. This is the penalty. So until you will not understand the meaning of this particular thing, you will not understand that how the model is going to be trained. And the average score is -0.4. So the thing is, these are different terminologies that we need to understand when we are going to train any of the machine learning model.
Okay. Thanks, Nitin. We have one question from the YouTube live audience asking, any reference where reinforcement learning is used to manage marketing campaigns?
Currently, I don't have, but definitely I can, provide some links to you later this webinar. So what you guys can do, as I have provided my email ID here, so and LinkedIn contact profile, so you guys can connect me on here, and definitely I'll provide some good resources, whichever I have right now, right? So this particular PPT. I will also share with everyone. So,
sure, Nitin. We have a few more questions in the chat. We want me to go through this?
Yeah, so there are a lot of questions. Let me answer one by one. What is the percentage of accurate for RL can expected? There's no exact percentage that we can say for any of the machine learning model, neither for the RL nor for the supervised learning models. It totally depends on your use case. And sometimes you get 70% of accuracy and you say, oh, yes, your model is working fine. Sometimes you get 100%, even or not 100%, even 99.9% accuracy. And even at that time, you say, no, we are not satisfied with the accuracy. So it totally depends on your use case and how much the data you're having to train your model. Questions on from YouTube, Ashok Veda. Any references where reinforcement learning is used for managing market campaign? So
yeah, you just told me
currently we don't have. Can we use reinforcement learning we used in supply chain domain? Yes, exactly. If I'll be saying, as I've given you one example of the car manufacturing company where the automation is still in the process, but for some smart work, we are currently using the human beings, right? If I would like to give you one more demo. Suppose we are having one water bottle manufacturing company, right? And we have placed one robotic arm or one automation system which is picking the water bottle in every 1 second with a delay of 1 second. One bottle is coming and then it is picking after every 1 second. Suppose the gap between the bottle is different and or by mistake, the robotic hand which is picking up the bottle is picking the bottle in spite of 1 second, it is picking up in 0.9 second or 0.8 second. So these kind of issues cannot be resolved by the automotive system. So for here, we need the intelligent system. We need to place a human being for that. So for such kind of, to design such kind of intelligent system, the RL is used there, right? So for the supply chain domain, definitely it can be used. But currently, we don't have any such kind of system which we are using. Even I don't know any such kind of model has been developed for the supply chain domain. If we want to start learning reinforcement, which part should we choose? Focusing in Python framework like TensorFlow, PyTorch, at first we should have very good base of mathematics and statistics. Okay. So what I would say here, we don't need to have very good base of mathematics and statistics, but yeah, we must be having an understanding. And even it's a supervised learning, unsupervised learning, or the reinforcement learning, any type of machine learning, until and unless you don't know Python, you don't know algorithms, you don't know, programming concepts, I think you cannot start with these things, right? So you must be having good hands-on with any of the programming language, maybe Python or C++. Both are widely used right now, but Python is most popular. So you must be having good understanding of Python to write the frameworks, to write the different algorithms, because each and everything is written in Python. So you suppose one model is already created and you would like to make some modifications in that. So definitely, these things are very essential when you are going to learn any of the machine learning. It's not about the reinforcement, it's about any machine learning algorithm.
We have more question where we are asked whether we can build gaming bots with reinforcement learning.
Sorry, can you please repeat?
The question is, can we build gaming bots?
Yeah, definitely. There are a lot of gaming bots has already been created, not physically, but virtually. There are a lot of games. Gaming bot has been created because some time back I find some links of different agent or different websites which are providing the cracking of those games. I mean, so there are some bots that we can download in our local system. Then after, when we will be playing that game online. We don't need to do anything. We don't need to place any key to play the game. It will automatically detect the right keys, and even if you're not in front of a computer, your computer will automatically, cross all the labels of the game. So yes, the bot are existing these days, not physical, but on the software side, they are available. And about the physical bots, a lot of the research is going on. So currently, we have no idea. But in near future, we will definitely have the gaming bots, maybe the physical gaming bots we may have.
Yeah, we have time just for one last question. It's from the YouTube participant who's asking, what are the challenges involved in, upcoming challenges faced in this field of reinforcement learning?
Yeah, I think I already answered this question. Like the first thing is, in this particular reinforcement learning, we don't have the much data. So we need to generate the data first, because the model, any type of model which you are going to create in machine learning, it requires the data. Even in the reinforcement learning, when you were seeing the demo of the self-driving car, it was creating some data initially, right? Like we were having 3 sensors, and every time it is, capturing the distance between the obstacle and the sensor. So it was generating the data. So in the reinforcement learning, we cannot use the pre-available data. If suppose someone has made the images of dog, that data of any other resources or of any other person, we cannot use in the reinforcement learning. For every reinforcement learning new project, we have to make our own data. So developing the data and on the data to train the model is a big challenge. To get the data is the main challenge for the reinforcement learning models.
Okay.
Yeah. When we do PhD, we analyze models such regression, cluster, or other for data. For our data, can we consider as data science? I think we must understand what's the difference between the data scientist and the machine learning engineer. What data scientists do, it play with the data. Whatever the data suppose there's an organization which would like to predict what is the sale in every month of the organization. So the data scientist will give the answer for that particular question to the management. But data scientists can take the help of the ML engineer and can ask them, can you please predict the sales data of this particular product of this in previous 8 months we get this much of sales of this particular product. What could be the tentative sales of this particular product in next month? So machine learning engineer will create the ML model to predict these predictions using the data which is available for the training, right? And data scientists will help you to visualize to give some visualization to that particular data to present to the management, because management is not going to care about your models, your how you develop the models, what is the outcomes of the model. They don't care about it. They only take care about the figures, that what is the exact number that is going to be affect the company sales or company profit balance sheet, right? So that work was done by the data scientist. But I would like to add one line here. It depends on the different organization as well. Maybe you are going in an organization as a data scientist, but you will do the machine learning engineer job there. So the profile job is totally depends on the requirement of the project. So, but at this point of time, machine learning engineer and data scientist are doing somewhat the similar job, but their job profile is quite different. So it depends on the industry to industry, organization to organization. I hope I was able to answer this question.
Okay. I think that's more or less like, the questions we are done with for today. Thank you so much for taking the time out, Nitin, and helping us put forward your presentation on reinforcement learning. And thank you everybody for joining today's session. We'll keep you posted for the upcoming sessions going forward. So keep in touch, and we will get back to you very, very soon. Thank you so much for your time, Nitin. Have a nice day, everybody.